Welcome to the fifth episode of the Trigonometric series and the third episode of kind of this mini series that we've been doing that's just explaining trigonometric identities in relation to the angles. And these are, of course, very, very important. So last episode, we ended off without looking at the double angle formulas for cos, sine, and tan. So we'll be looking at that today, and of course, we'll also be looking at half angle formulas. So taking a look at what is the relationship between sine of theta over 2 and sine of theta, and so on. All right, so first of all, let's look at the double angle formulas. And a very natural way to proceed is just use sine of theta plus theta. After all, we already know how to add angles in relation to sine and cos. So 2 theta is of course just theta plus theta. So we can just use that. So sine of 2 theta would be sine theta cos theta plus another sine theta cos theta, which simplifies to 2 sine theta cos theta. That's pretty nice. Cos 2 theta, again, we will just use theta plus theta, and we will get cos squared theta minus sine squared theta. Great. And now tan 2 theta, again, use tan of theta plus theta, and we will get tan theta plus tan theta on the top, and 1 minus tan squared theta on the bottom, and this simplifies to 2 tan theta over 1 minus tan squared theta. All right, the last time I said there was actually 3 forms to this cos of 2 theta expression. So let's take a look at how we can actually make this into 3 forms. And kind of the only way to do it is by trying to manipulate where we have our coses and sines. So recall that sine squared theta plus cos squared theta would be equal to 1 for any angle theta. So what we can do is we can try to get an expression that has only sines or an expression that has only coses, and those are in fact the other 2 forms of this formula. So we could take this cos squared theta minus sine squared theta, and if we wanted to get rid of the cos squared, we can plug in that cos squared theta is 1 minus sine squared theta. And so we could say that it's equal to, 1 minus 2 times sine squared theta. Now, on the other hand, if we wanted to only keep the coses, then we would replace the sines with the coses. So we would say cos squared of theta minus sine squared of theta. Well, sine squared of theta is 1 minus cos squared of theta. So this is going to be cos squared theta minus 1 minus cos squared theta. So this would be 2 cos squared theta minus 1. Great. And let's see how this will apparently be useful towards figuring out the sine and cos of the half angle formulas. So let's take a look at sine of theta over 2. Now obviously, I want to use some sort of trick, right? And these double angle formulas, of course, should go in conjunction with the half angle formulas. It only makes sense because applying the double angle formulas onto this half angle will net me back to a sine theta. So let's see what happens if we just try to use the sine theta expression. So what do I know? Well, I know 2 sine theta over 2 cos theta over 2 is equal to sine theta. Well, this is kind of no good because I have these two half-angle formulas, and I don't want to relate them to each other. I only want one of them by itself. So this kind of tells me that the sine theta or the sine 2 theta formula is not going to really work for this. And so let's look at the other one, which would be the cos. So if I just have the form cos squared theta minus sine squared theta, again, if I try to apply that, that will have cos squared theta over 2 minus sine squared theta over 2. Again, I have some sort of a relationship here, but I only want sine of theta over 2 by itself. So I'll use this form, 1 minus 2 sine squared theta. And so what I'll get is that cos of theta would be equal to 1 minus 2 times sine squared of theta over 2, right? You can see here, I'm just replacing the theta with theta over 2. So this double angle formula will be cos of 2 times theta over 2, and so I'll get this expression. That's of course wonderful, because now I can relate it to one of the sine theta or cos theta. So what I'll get here is just after a bit of rearrangement, so we'll have sine squared of theta over 2 is equal to 1 minus cos theta over 2. Then I'll take the square root, so sine of theta over 2 is equal to square root of 1 minus cos theta over 2. Now, there should be a glaring problem here. And the problem is, well, how do I know if the sine theta over 2 is positive or negative? Well, it can actually be both. And here's the reason why. So imagine I have an angle, right? So just for simplicity, let's say that theta is right over here. So that means that theta is an angle of pi. Then, where I expect sine of theta over 2 to be, well, theta over 2 will land me right at this top part here. And so my sine I expect to be 1. So let's look at it this way. What if, for my angle, I had negative theta? Or if I had 3 theta? Well, sine of negative pi and cos of negative pi still matches up with positive pi and still matches up with 3 pi because I went around the circle, so I should still expect the same sine and cosine values. However, when I take the half of negative pi or 3 pi, I actually end up at this bottom over here, which is a negative 1. So we can see that there's going to be two possible values, and it basically just depends on how many times we're going around the circle, because this time it actually affects the answer. So the general answer will be sine of theta over 2 is square root of 1 minus cos theta over 2, but then you have to check the sign depending on what your angle is, which answer makes sense. And we choose that one. And so very similarly, we're going to see that cos of theta over 2 is going to use a very similar process. We're going to say it's 2 times cos squared theta minus 1, using the last form that we found anyway of the double angle formula for cos. And then we're just going to do some rearranging. But we're not going to do some rearranging because we actually wrote it backwards. So it should be cos of theta over here and theta over 2 over here. So now we have cos theta plus 1 over 2 is equal to cos squared of theta over 2. And so cos of theta over 2 is equal to square root of cos theta plus 1 over 2. And again, we're going to have issues depending on if it's positive or negative. Great. So the last thing we're going to discuss is the tan formula. So of course, a very natural thing to do is, well, tan is actually kind of hard to work with. So let's just work with sines and coses. So this will be sine of theta over 2 divided by cos of theta over 2. Aha, well, we just did those. So let's sub those in. So sine of theta over 2, as we can see over here, is square root of 1 minus cos theta over 2. And cos of theta over 2, well, it's right over here, is square root of cos theta plus 1 over 2. All right. Now let's see. Well, we can cancel the 2, the root 2 on the top and the bottom. So we'll get square root of 1 minus cos theta over square root of cos theta plus 1. Great. But it's actually not so great. So even though we got a formula for tan of theta over 2, it has a bunch of radicals. And radicals are, of course, not the easiest to work with because square roots of trigonometric functions, well, that's just hard, right? So let's try to find a way if we can try to make it easier. So one thing that we do is we can rationalize the denominator. So let's just take the bottom and let's multiply it by square root of cos theta plus 1 just to get rid of the square root. And so we have to multiply the top by this as well. So now on the bottom, we just get our cos theta plus 1 as normal. And on the top, well, we can recognize it's just a difference of squares. So we will get square root of 1 minus cos squared theta. But of course, square root of 1 minus cos squared theta, well, I know that sine squared plus cos squared is 1. So 1 minus cos squared theta is the same thing as sine theta. So we can write that it's equal to square root of sine squared theta, which is sine theta, divided by cos theta plus 1. And that's a much nicer formula because now we don't have the square roots. And we could even say that sine theta is probably easier to work with than 1 minus cos theta. So overall, we made this formula a lot easier. So in the end, we can say that tan of theta over 2 is equal to sine of theta divided by cos of theta plus 1. And that's it. So for next time, we're going to be looking at things that don't really involve angles anymore. We're going to be looking at sum to product and product to sum, trying to simplify having two trigonometric formulas multiplied together versus having two trigonometric functions added together, and then we'll try to see how we can swap between the two.